For our next speaker, Eric Kosman specializes in the application of information technology to all areas of manufacturing and engineering, including the definition of policies and practices, system and technical architecture, and technology management and integration planning processes for manufacturing and engineering systems globally. With over 30 years of experience, Eric has held positions in both Canada and the United States in areas including process engineering, process system software development, telecommunications, IT operations, architecture definition, and consulting. Eric has held leadership positions in various industry groups, standards committees, focus groups, and advisory panels. He has written and spoken on topics such as technology lifecycle management and the use of standards as a basis for a manufacturing information systems architecture in support of operational excellence. Eric is an industrial leader in the area of industrial systems cybersecurity with a specific emphasis on the implications for manufacturing operations. He is a founding member of the current co-chairman of the ISA 99 Committee on Industrial Automation and Control Systems Security and the Vice President of Standards and Practices at the International Society for Automation. He has been a member of the steering committee for the chemical sector cybersecurity program, which is associated with the American Chemistry Council, and represents the Chemical Sector Coordinating Council in the Industry Control Systems Joint Working Group with the U.S. Department of Homeland Security. He was one of the authors of the chemical sector's cybersecurity strategy for the U.S., originally published in 2002 and updated in 2006. Please join me in welcoming Eric Kosman.
But February made me shiver with every paper I deliver. Bad news.
What he didn't say is that I probably have the longest introduction in the program, and for that I apologize. I guess I assumed that it would be edited a little bit for brevity, but what's not mentioned in the introduction is that my day job, I work for the Dow Chemical Company. I'm not here today speaking for the Dow Chemical Company, so I'm not really talking about specifics and particulars of our program. This talk is a version, extracted, I guess, from an article that I've written for Chemical Engineering Magazine that's going to appear in the June issue. And it's an area that I've got quite a bit of passion and interest in, and that is helping people deal with the sometimes challenges that are associated with and operating an effective cybersecurity program in their operations. So to get started, let me ask a question of the audience. How many people representing or owner-operators? Okay. And how many people are involved in planning and delivering your response to the cybersecurity issues in your company? Anyone? Sounds like my mic is cutting out. Okay. Basically what I want to talk about in the next little while is the challenges facing people as they build their cybersecurity program. I think I can skip over this one. My introduction says 30 plus years, this says 35 years. Do the math, I've been around a long time. So basically, as I said earlier, what I'm trying to get out to people is help and assistance in how to plan their cybersecurity program, because there's an interesting dichotomy going on here, is that some people will say, I don't know what to do. I don't know what information to use, there's not enough information, and that was probably the case several years ago. Now we're in sort of the opposite situation. There is almost too much information available, and it is bewildering sometimes and very confusing for people trying to figure out exactly what they should pay attention to. If you're in the energy sector, NERC-CIP is pretty clear, okay? And for compliance purposes, it is very clear. Now, I would submit to you that compliance to the NERC-CIP is not enough. It's a darn good start, but it's probably not enough. But for other sectors, and particularly for smaller to mid-sized companies in some sectors, it's very difficult to know exactly what you should do and how far you should go. So anyway, that's the genesis of this talk. The topics I want to cover, first of all, the ever popular and provocative topic of IT versus OT, or IT versus engineering or manufacturing. It's not really versus. You'll see I've used the word and here. One of the themes of this conference being connecting the dots. Some of the dots that have to be connected are interdisciplinary dots. And I always, when I talk about this subject, I always start with a bit of a story. Probably 10 or 12 years ago, I gave a talk at a conference on the subject of IT and engineering working together. And at the end of the talk, a gentleman raised his hand and asked a question. And he said, I just have one question. And I said, what's that? He says, how do I keep those blankety blank blank IT guys out of my plant? And I said, well, with due respect, sir, you've missed the entire point of my presentation, because you're not, it's not keeping them out, it's basically figuring out how to work with them. So that's the theme of that particular point. We really have to change the conversation, and I'll get into that in just a little bit about how to do that. And then once you've sort of established that philosophy or that way of doing things, that way of thinking, and get out of that adversarial mindset, now you've got to get to the hard work. How do I create my program? What are the components of a program? How do I go about setting it up? And through a lot of the work that I've been doing in ISA and the International Society of Automation and in the standards area, our committee, which is actually something like 400 people on our committee, I wish they were all actively contributing, but at least 400 names on the list. We've coalesced a small number, I think it's 6, fundamental concepts that we feel are essential to building an effective industrial control system security program. So I'll talk about those fundamental concepts. And then I'm going to go into just a very quick overview of some of the more topical, current, and useful sources of assistance, places where you can go for practical, useful, actionable information. And I'll touch at the very end on a couple of general applications. And again, I won't get into a lot of specifics. I'm not here to, as I said, to talk about specifically what Dow or any company is doing, and I'm certainly not here to endorse any particular products or solutions. So let's start with this IT versus OT. Old wine in new bottles. This has been around forever. Certainly long before the cybersecurity issue came to the fore some 10 or 12 years ago. And actually it came to the fore before that. I worked on our internal control system security program in Dow as far back as about 1988. So we've been struggling with this for quite a long time. If you want to have a little fun, go onto your favorite search engine, Bing or Google or whichever one you happen to use, and do a search for phrases like OT security or OT versus IT. And you'll find some very interesting articles. A lot of people have been writing some very, in some cases provocative, but in many cases informative material on this subject. The distinction is real. And by the way, this OT term is relatively recent. It's becoming more popular in the trade press now, operational technology versus information technology. The distinction is definitely real. When you start taking information, generic information technology and applying it in an industrial context, there are some new things to think about. There are some new rules to apply, there are some new constraints and basically some new cautions that you have to worry about. And I think I'm probably preaching to the choir in this audience. We all know that. It's always fun to take someone from your IT organization who's probably never been out of what we call the head shed or the corporate center and take them into a plant and show them around. And it's interesting. In one anecdote I will share from our company, we work very closely with our IT organization. I work in manufacturing and engineering. And we encourage moving people back and forth between the organizations to give them a more well-rounded exposure. But I get calls all the time from our IT people saying, hey, this isn't working, this back and forth thing, it really isn't working for us. And I say, well, what do you mean? He says, well, we take our best and brightest and we send them over to you to work in your area for a while, and they don't want to come back. And nobody in your area wants to work in our group. So how come you're getting all our good people and we're not getting anybody back? And I say, well, I don't know what to tell you, you know. Once people get a taste of working with information technology tied to things that actually move and tied to the real world, they find that pretty cool. And they don't necessarily want to go back and work in finance after that. That's their choice, not mine. But anyway, understanding these differences is really essential for an effective partnership between these two disciplines in many areas, and security is only one of them. But there are others, like operations, capacity planning, network design, many of which I've done over my career. I've gone back and forth between IT and engineering several times, and I've done everything from run a networking and communications group at a site level to doing wide area network design for a large-scale SAP implementation to developing software for, I guess you'd call it today, HMIs before there were commercial HMIs. That tells you how old I am. So I've had a lot of years to observe the similarities and the differences. This graphic, when I did that search that I told you about earlier, I came across this article, and if you can read the fine print at the bottom, that's the actual reference. But this gentleman that wrote this article did a very, very good job, probably not, you know, the definitive job, but one of the best I've seen of summarizing the relationship. And he used this graphic that you'll see here, which is basically that the information technology infrastructure is, in fact, infrastructure. It's the piping, if you will, and that the value added is what goes into the pipes. And of course, as a chemical engineer, this analogy appealed to me. I started my career as a process engineer, designing piping and process equipment and so forth, so this was a trip back to the past. But I would encourage you to look up this article. It's very balanced and very informative and yet quite brief, so he does a very good job of summarizing the points. And this is an eye chart. Don't try to read this, but this comes directly out of that article. And he does, again, in the article, I think, is a succinct but effective side-by-side comparison of the two domains. And we could have these discussions, the similarities and differences, until long into the wee hours of the evening at a bar someplace. And believe me, I have had many of those conversations. And the opinions range all the way from the gentleman I mentioned earlier, which is keep those blankety-blank guys out of my plant, all the way to the IT side of people saying, why do they hate me so much? I didn't do anything to them. So the fact of the matter being, and again, I don't want to belabor the point, but effective partnership is really what's important. So in the ISA 99 committee several years ago, we came up with this pseudo-mathematical formula, and we said that effective automation system security, to do it effectively and comprehensively, you need a dollop of the appropriate IT security technology. So as we've seen, as we survey technologies, we need to know about firewalls and data diodes and demilitarized zones and network capacity planning and switches and networks and servers and so on and on and on and on. So there's some of that that's necessary. And with some, well, probably quite a few exceptions, a lot of plant engineers don't really want to know about that stuff. That's not what they signed up for, okay? A control engineer working in a plant, many of them that I've spoken to see this as a necessary distraction, all right? So if they could get help with some of this stuff, that would be great for them. You also need some specialized security expertise. And the gentleman who introduced me this morning talked about, you know, learning to be a little less trusting. I describe security professionals as people who are paid to be paranoid. So there's a certain amount of that comes into this. But the underlined and bolded portion that is sometimes overlooked is industrial automation domain expertise. You can hire the best, scariest IT security professional, and believe me, I know most of them in the field. Several of them I describe as I'm glad they're on my side. But if they don't know a little bit about what the purpose of that system is and what it is, what's involved in operating a plant and keeping it running safely and reliably, chances are you're going to get the wrong answer. So you have to tie them together, if you will, blend them in with this automation expertise. So there are lots of questions that come up as you have this conversation, as you bring these constituencies, these groups together. And this is just a sampling of them. So, you know, some of them are very technical in nature. Do we have separate? Do we have interconnected networks? Data diodes as a physical separation, is that what we need? Or can we use, are firewalls effective? And there's all kinds of what I call holy war discussions about those kinds of things. What are the real threats? Time and time and time again, I hear people say, I don't have anything anybody would want to steal. I'm just this little plant over here in the corner someplace in the northeast, southwest, pick something. And why should I feel afraid? And we'll get to that in a moment. How do I manage patches or change management of change that was touched on by Leslie? Patch management is change management, okay? And it's just one type of change. How do I manage risks? We'll talk quite a bit about risks in a moment. What are the technologies and products available? They're changing all the time. One of the things that we're doing, one of our deliverables or our work products in the ISA 99 committee is a technical report that surveys security technologies and their applicability for industrial automation. And there's a revision, a third revision of that being worked on right now. And it's been published twice, published once, updated once, and will be updated again a second time. And then the last point there, IT or engineering. This is always the fun one, right? Who's in charge? Who's in control? You know, it's IT, who owns the technology? Who owns the installation? That's another one that can cause all kinds of sort of hair-raising discussions. As I said earlier in the introduction, we have to change the conversation. Less fear, uncertainty, and doubt, or Fudd. We've all heard the Fudd term, right? Time and time again, we hear people saying, they go to plant managers or section managers or executive leaders, and they say, these are all of the scary things that can happen to you if you don't do something. Well, there's a certain amount of benefit to being provocative. But if you have someone that really doesn't know what they're talking about in terms and has no experience and credibility in operating manufacturing facilities, in other words, pure security person coming and telling someone in operations all of the terrible things that can happen to them, they don't have a lot of credibility. Because if you're operating and managing an industrial facility, your job is risk management. You manage risk every day. It could be risk from weather events, it could be risks from equipment failure, it could be risks from any number of things. And cybersecurity is just another one. Now, it's different, definitely, but it is still a risk. And the fact is, you know the consequences. And I'll get to the importance of consequence in a moment. But the focus needs to be on process capability and potential consequence. And who knows the consequence best? The people that own the facility. They know all of the bad things that can happen, irrespective of what may have triggered those events or what may have triggered those consequences. They know what the bad things are that can happen, be it loss of containment, be it reactive chemicals incidents, all sorts of things. So the other advice I give people when you talk to operations management is speak in plain language, not cyber speak. Everybody that's a professional has a second language, and it's the geek speak of your profession. Whether you're a chemical engineer, whether and you're talking about thermodynamics and stoichiometry and control theory and stuff like that, or whether you're a security expert or whether you're an IT expert, it doesn't matter what your expertise is, you have your own geek speak. And try to avoid the geek speak. And that's kind of communications 101. But most importantly, know what you're trying to achieve and why. And speak to people credibly about what you're trying to achieve. And believe me, I'm sure most people out here have encountered this and have this experience. I've got this proverbial 30 plus years of experience of talking to vendors and technology providers, and with what they're trying to achieve is to sell me their technology, and the why is to improve their bottom line. That's pretty obvious, really quick, okay? So that doesn't do much for me. Another pseudo-mathematical formula, and this is when we get into risk. As I said, if you're operating a facility, you are a risk manager. You are managing risk every day. The general definition of risk is a product or a function of threat, vulnerability, and consequence. All right, now, I'm not a risk management expert. We have an entire division of our company that does that. We're self-insured, so we do a lot of that kind of stuff internally. But I've learned enough over the years to know that it kind of boils down to these three elements. And each one of these elements has a certain response and has a particular perspective that comes with it. But I want to talk to you about consequence. A lot of the theme, and if you do perchance happen to find the article that I wrote that will be in the magazine next month, I don't know. I'm not a subscriber to Chemical Engineering Magazine, but they were kind enough to send me a copy. And I've written in other periodicals about this too, but the real press here is consequence. That's where we need to focus on as the people who own and are accountable for the assets. But before I get to consequence, let me just talk briefly about threats and vulnerabilities. Threat information is generally gathered as a result of intelligence gathering. Now, that's a fancy word for, it could be as simple as reading the ICS CERT alerts that come out on a regular basis, or talking to your colleagues and peers, or maybe getting information through FBI's InfraGard program. But basically, you're gathering intelligence. And then you have to somehow translate that threat into your context. Is it a threat for me? So when somebody says, oh my God, Heartbleed is the latest thing that's going to be the end of the world in IT security, well, what does that mean for industrial security? And you have to get somebody that you can trust to help you make that determination. Threats are often vague and very nonspecific because they're very general. So there's this vulnerability that has been exploited. It's a 0 day, or it could be an infinite day. I'll talk about that in a minute. But we've all heard there's a virus in the wild. It's out there. And as I mentioned, some of the best sources are US CERT, ICS CERT, some of the antivirus companies. Kaspersky is a very good one, McAfee, they all gather this information. The Verizon data breach reports that come out once a year. Some of the details might be classified or otherwise protected. If you're getting information from the US government, they do, and I believe and I just came in at the very tail end of her talk yesterday, but the lady from the FBI put up a slide about for official use only. So the FOUO designation is sort of the lowest level of restriction, and then you go all the way up. There's secret and top secret and so on and so on. If you have people in your organization that have a security clearance with the US government, they will get access to some information that other people don't get access to. But the context is really what's important. Vulnerability, we all see those. We're in the technology business. To my knowledge, nobody has ever written software that's perfect yet. And vulnerabilities are constantly being identified, Heartbleed being one of the ones that just came out recently. There are people out there that spend their lives punching holes in software, finding the weak spots. And they're discovering these vulnerabilities. And actually, vulnerabilities have a currency now. You can sell them. You can actually find one and sell it to somebody either for nefarious purposes, or you can, some of the software companies are paying bounties to people who find them. So well-crafted malware can exist, and it can exist for years in some cases before it's even detected. It's latent. It's in there. Nobody's found it yet. Obviously, nobody's exploited it yet. So you ask yourself, does the mere presence of a vulnerability mean bad things can happen? Probably not right away. It's not a direct line relationship, although eventually something bad could happen. But as I said earlier, I want to talk about consequence. Asset owners need to be aware of threat and vulnerability, but they need to focus on consequence. This is our wheelhouse, all right? What could happen? We, as the asset owners, should know that the best. We need to be realistic, but at the same time, we need to look into areas that may not be obvious and may not be, you may not leap to right away. People make mistakes. They don't always do what they're expected to do, especially when they're under stress. And in some cases, those mistakes can lead to incidents. And there's a raging debate in the community about whether or not an inadvertent act or a mistake should be classified as a cyber incident. There are different opinions on that question. So hit the wrong button. So anyway, as you're thinking of those consequences, I did it again. Okay, as you're thinking of those consequences, be careful when people make statements like, well, that couldn't happen here. you know, or no, I'm too smart for that. I've actually had people say, what do you think, I'm not stupid, I don't do those things. Or why would anybody do that? People make mistakes, we're fallible, we're human, that's part of the human condition. So that's part of risk management, part of, you know, whether you're doing it for cybersecurity reasons or whether you're doing it for safety reasons, people ask those questions all the time. What could go wrong? So once we get a good understanding of the consequence, and by the way, I just mentioned safety, there's a very, very strong correlation here between cybersecurity related analysis and process safety related analysis. Because after all, for the prime directive for most of us that have assets that we're running, plants that we're running, is be safe. Followed shortly thereafter by environmental, which, you know, you could probably argue that those two are roughly equivalent, and then it's be highly available, productive, profitable, all of those other things. But certainly safety comes first. So if you understand the consequences, now you got to figure out, all right, I know what could happen to me. Where can I get some assistance? Where can I get help? Who can I go to? And before you can really answer that question, you got to give some thought to how do I put my program together? What disciplines do I need? What expertise do I need? I have a term I use called targeted selection. When you're looking for people, be they candidates to sit on a board of directors or team members or whatever, you need to understand what skills you need and then target those skills. So you got to give some very deep thinking to exactly what your program should look like and where your weak spots are. And then as you're designing that program, no surprise here, I don't care what kind of a program it is, security or anything else, it all comes down to people, process, and technology. And then, of course, you have, this is sort of straight process improvement methodology, whether it's Six Sigma or whatever the methodology you use. Look at your current performance, identify your objectives, and then put in some, establish some measures so that you know you're actually moving in the right direction. I mentioned the fundamental concepts. By the way, all of this is explained in more detail specifically in the context of cybersecurity management or industrial control system management in the ISA standards, specifically in this particular case, ISA 62443-2-1. And by the way, just in case that number is unfamiliar to you, ISA 99 is the committee. The work products from the ISA 99 committee are given the designation 62443 because that was the IEC number that was assigned, and we are releasing our standards in conjunction or coincident with ISA and IEC at the same time, simultaneously, ISA and IEC. I'll be talking this afternoon in a breakout session on a lot more of how the sausage is made about standards, so I won't go into that here. These fundamental concepts, as we've analyzed this subject and debated it and discussed it and developed all of this material, we come down to these 6 fundamental concepts: security lifecycle, zones and conduits or network segmentation, security levels, foundational requirements, program maturity, and last but absolutely not least, this is in no priority order, safety and security. And I'm just going to touch on these very briefly and just to make you aware of them and maybe give you some references where you can go look for more information in the standards. So getting back to that sources of help question, who can I help? Who can help me? Okay? So in typical or approximate order of usefulness, that OT-IT partnership that I talked about, don't discount it. Don't take the attitude, how do I keep those blankety-blank people out of my plant? Approach them, talk to them, listen to them, get their expertise. I get back to that point. Most control engineers don't want to be IT experts. If they could get the help that they need in a form that they can use, that alleviates them from worrying about that and allows them to, what I call, practice their craft. Do what they are hired to do. If they're control engineers, if they're operations engineers, if they're maintenance engineers, it doesn't matter. They don't want to have to deal with that stuff, but they need somebody that they can trust who understands the context. So build that partnership, craft that partnership. In our company, we've been building it and executing in it and operating within it for years, maybe going on decades. So that's a very, very important. I can't stress that enough. Practices and guidance, and even regulation, like in the case of the energy sector with NERC-CIP, but practices and guidance. Most sectors have come together in one form or another through a professional or an industry association, whether it's the American Gas Association or whether it's, what do they call it? It used to be NPRA, they've changed their name, or whether it's the American Chemistry Council, and they've produced guidance by collecting the best available knowledge from their membership and have made that available to their members of their sector. So that, I would encourage you to reach out to sector organizations like some of the ones that I've mentioned. Standards, of course, are important, but most standards are not written to be read by the average person. They require some interpretation. They have their own lingo, their own, they talk about normative requirements versus normative language versus informative language, and they get pretty esoteric, but definitely they are solid reference material. I am most familiar with the 62443 series, but there are other standards like ISO 27000 series for generic IT security. And you know, I don't encourage people to read those things cover to cover because it's a good sleep aid. You know, you put you to sleep pretty quick. And then lastly, I talked about expectations and regulation. If you are in a regulated industry like energy, or in the case of the chemical sector, we have the DHS, I can't think of the acronym now, but our regulatory agency in the United States is the Department of Homeland Security, and we have some regulations from DHS that we have to adhere to. Reference sources, it's an alphabet soup. There are lots of stuff, there is lots of information out there, and figuring prominently in this space is the ISO 27000 series, starting with 27001, as well as the ISA standards, the 62443. There's also relevant information from the National Institute of Standards and Technology, NIST. I put a plug in for them. They just recently issued, recently I mean last week, recently issued a significant rewrite to their special practice 800-82, which is specifically addresses cybersecurity for industrial control systems. So if you're interested in that, it's some 235 pages, but it's got some good information in it. And if you just do a Google search on NIST 800-82, you'll find it. And as you can see, there are lots of others in there. Not to you know, NERC-CIP has already been mentioned. Some of the Department of Energy materials. The one at the bottom in the center is a private sector framework that has recently come out from the Langner Group. Ralph Langner and Perry Peterson have a small consulting company, and Ralph has done some very interesting research and sort of collected that in this RIPE framework, and I can't remember what RIPE stands for. Risk, I think R is risk, but I can't remember the rest. If you're not familiar with Ralph's name, he is the guy that broke the Stuxnet story. He's the one that did the reverse engineering on Stuxnet. And if you have heard his name, that's probably the context that you heard it in. So real quickly, I'll go over a little bit on the 62443 standards. I've mentioned those already. It's a series of, let me see, 1, 2, 3, 4, 5, 6. It's something like 13, I think. If I may have a chart in here on this. Standards and technical reports on various aspects of industrial control system security. As I mentioned, we are doing this in conjunction with the IEC, so ISA 99 and IEC Technical Committee 65 Working Group 10. There'll be a test afterwards with all of this number and jargon. Are doing this in cooperation and working with ISO, so the committee has formal liaison relationships with IEC, ISO, and several other groups. There we go. That's the, so it's what, 8 and 5 is 13. I was right, 13 parts. And some of them are already available. Others are available in draft form but have not been formally approved, and only 2 of the 13 are still in the idea stage. They've been proposed, but pen has not yet been put to paper, or whatever the electronic version of that term is. Moving on to other things, if you've been reading the news in this area and following developments in this area in the past year in the United States, you'll know, or you at least may be passingly aware, that President Obama in February of 2013 issued Executive Order 13636, which was titled Improving Critical Infrastructure Cybersecurity. This was an executive action taken largely, well, at least partially, as a result of the fact that the legislative branch, the Congress basically, had not been able to pass legislation. So President Obama issued this executive order. And as a result of that, that order directed the Department of Commerce to develop a framework for effective cybersecurity in the critical infrastructure. The Department of Commerce immediately went to the National Institute of Standards and Technology, NIST, and had them lead the program. And they developed that framework and delivered it in February of this year, so exactly 1 year later. And that information is all publicly available, and you can use material on these slides to do the Google search, and I actually may have the references in here. But it's an excellent source of guidance on how to, not what your program should contain, but how to structure your program. It's a very good roadmap about how to get started. And then it gives references of applicable standards and guidance material on the various aspects of your program, including the 62443 standards and the 27000 and NERC-CIP and others. So you can use this framework now, and you're encouraged to provide feedback to NIST, because the first version is exactly that, the first version. There will be subsequent revisions and refinements and improvements. The framework was developed through a series of workshops conducted throughout 2013 and at various locations around the country, typically at university campuses. I think there were 6 or 7 of them. I attended all but one. And so it was a very open, collaborative approach to developing this framework. As I mentioned, the various groups have contributed to this. I attended largely representing the Automation Federation, which is the umbrella organization of ISA, and there were many, many other groups and constituencies represented. NIST is very committed to helping not only develop and refine this framework, but helping people, to the extent of their resources allow, helping people apply it and get the feedback necessary to make it better. There's the URL. You can go get the information about the framework from this location. It's all freely available. And this is just an add-on to this. Remember, I said NIST developed this. They did the heavy lifting at the behest of the Department of Commerce. And I said the Department of Commerce. I meant Department of Homeland Security. Department of Homeland Security asked NIST to do this. NIST is part of the Department of Commerce. After the framework was developed, Department of Homeland Security developed and provided some additional material and sort of on how to apply how to use the framework, how to get assistance in using the framework, and they created this thing called the C-Cubed program, Critical Infrastructure Cybersecurity Voluntary Program. And this is also available on the DHS website. Material on this is on the DHS website. And so if you think of the framework being your roadmap, and then there's some additional information as to how to read the roadmap, that comes into this, under this area. Next item I want to mention, and I apologize, I'm skipping through these pretty quickly because I only have limited amount of time, but my intent here is not to teach you about all of this information. It's to raise your awareness and hopefully encourage you to go do some research and maybe even talk to some experts about it. And certainly, you know, if you want to contact me at any time after this, this conference, I'd be willing to talk to you about it. The next item I wanted to mention is something called ISA Secure. The Automation Federation, again, I mentioned the parent organization of ISA, has something called it's called ASCII, Automation Something Compliance Institute, which has a couple of groups or divisions in it, one of which is the Security Compliance Institute, the ISA Security Compliance Institute, or ISCI. And have developed a compliance program to ensure that technologies and products meet a minimum level of security. So the way I like to explain it is products don't come out of the box secure, they are securable. So they don't have obvious flaws, and they can be used to construct a secure system. So you want some assurance. Think of it like an underwriter seal of approval, all right? Or a good housekeeping seal of approval or an underwriter stamp. ISKI is one of several, but it's the one that or ISA Secure is their trademarked label for it, is one that I wanted to speak to today, just to make you aware of it. I am the liaison representative between the committee developing the standards and the Compliance Institute developing the compliance specifications. Once the specifications are developed, the actual compliance assessment is done by independently accredited laboratories. ISA or ISKI does not do the actual compliance assessment. So the idea here is in that last bullet. Asset owners should have confidence that the industrial automation and control system products that they purchase are robust against network attacks and are free from known security vulnerabilities. This will be a long road, but the hope is that over time we will, as an industry, develop more robust and secure or securable products. And so this slide just talks about, as I mentioned, the compliance regimen that's been developed and the mechanism and the processes followed for developing said regimen are accredited by ANSI and some of these other seals of approval you see down here. Basically says that these were developed using accepted practices and effective practices so that you have a compliance program that actually makes sense. If you're familiar with safety certification from, say, TUV in Europe or Exida or companies like that for safety certified systems, think of this as security certification. Very similar. Some of the applications, I'm just going to touch on a couple because I'm running short on time, but system segmentation is an accepted concept now. System segmentation or zones and conduits, basically not treating your network as one big flat homogeneous network, but actually segmenting it, segregating it, and treating sectors or pieces of it differently depending on the level of sensitivity, the level of vulnerability, the decrepitness of your technology, and a bunch of other factors. So I could cite examples. I won't bore you with the details here, certainly in the interest of time as well, but there are many, many companies, both owner-operator companies or asset owner companies that are doing this, and vendors are starting to talk in terms of system segmentation. I mentioned program definition. So the various frameworks for developing your program, the RIPE framework, the NIST framework, and so forth. So that's becoming much more systematized, if I can use that, if that's a right word. People are taking a much more logical approach to developing their program. And as I mentioned briefly earlier, one of the areas that's really, I think, starting to catch fire is this collaboration between the safety and security community. Within the ISA, we have a division that is actually safety and security. But up until fairly recently, that's been largely a name only. But now we're doing much more direct collaboration. We have a joint liaison relationship between the ISA 84 Committee on Process Safety and the ISA 99 on security. And ISA 84 recently issued a technical report on this subject. So the two communities are really coming together and finding that they have a lot in common. So just in review, some of the things that I've talked about, I mentioned, I gave my little standard speech, stump speech on IT versus OT. And I really start to think of myself almost as an evangelist when I start talking about that topic, but it really, it just never goes completely away, so it's always out there. We talked a little bit about how to deal with that and changing the conversation and getting away from fear, uncertainty, and doubt and getting to a much more constructive basis. How to create the program. If you take nothing else from this talk, there is help out there. There's guidance. If you feel overwhelmed, help is on the way. It's not only on the way, it's here. There are people that can show you programs that have been constructed. There are people that can actually come in and review your program and give you a critique. In my company, we've done that. We hired a consultant to come in, look at our program, and give us a critique about what our soft spots were. The fundamental concepts that form the basis of the standards, at least the standards as represented by 62443, some of the specific sources of help. Reach out to your sector, reach out to your industry, come to conferences like this, form those relationships. And then lastly, very quickly on some of the applications. So with that, I have about 2 minutes left in my allotted time if there are any questions, and I thank you very much for your attention.
Chevy to the levee, but the levee was dry. Them good old boys were drinking whiskey and rye and singing.
Any questions? I love the music, by the way. I'll be around the rest of the day, so if you, yes.
Eric, do you expect the chemical industry to have compliance regulations promulgated anytime in the near future?
The short answer is yes. The question will become, the really interesting part of the question is, and again, I'm not a soothsayer, so I can't predict the future, but I would say it's highly probable. The question would become, where do they come from? Who forms those? And in the chemical sector, we've taken a very, and I'm a little out of my league here. Don't get me wrong, I'm not speaking at a policy level on behalf of the chemical sector. That's above my pay grade. But I will tell you that I've been involved in this chemical sector program for a long time. And we've taken a very proactive stance with the Department of Homeland Security and built a very positive relationship with them, with the idea that at some point in the future, some sort of regulation is going to be inevitable. So we would like to have a hand in shaping that regulation, as opposed to it being imposed upon us with little or no regard or experience about the realities of our industry. Does that answer your question? Any other questions, real quick? If not, as I said, I'll be around for the rest of the day. You know what I look like, so unlike the gentleman that stopped me out in the hall this morning because I didn't have my badge on, I think he assumed I was trying to...